Hi, I'm Kasani Piyamika, MS24910118. So, today I'm going to present my review paper on DDoS attacks in IoT devices. Here I will be discussing how DDoS attacks threaten IoT systems and why they are so dangerous and what we can do to protect against them. Let's start with the basics. The Internet of Things or IoT refers to everybody, everyday devices like smartphones, computers, and all other equipment that are connected to Internet. These devices make our lives easier by enabling automation, remote control, and real-time monitoring. However, this kind of conveniences comes with a downside. IoT devices are often poorly secured, making them easy targets for cyber attacks. So, first let's see what is the difference between DOS and DDoS attack. A DOS, one computer or system sends flood or traffic to overwhelm a target. It's like a website or server. So next, DDoS is it is in many computer or devices, often uh, controlled by a hacker. Send traffic to overwhelm a target at same time. A key difference between DOS and DDoS is one attacker for DOS and many attackers working together in DDoS. Let me explain how DDoS attack works in a way that's easy to picture. So hackers start to infecting devices like your smart camera, home router with malwares. This turns them into what's called bots or zombies. These infected devices uh, are then controlled remotely by the hacker, who uses them to send large amount of traffic to the target, like a website or server. Imagine thousands of IoT devices like your smart fridge, your security camera, even your baby monitor, all sending requests to single server at the same time. The server gets completely overwhelmed. For example, it's like a single cashier tries to handle a crowd of thousands. It crashes and suddenly no one can access the service. The scary part is it's almost impossible to tell the difference between actual attack traffic and normal traffic. Normal traffic and attack traffic. It's like a trying to spot a few fake tickets in a packed stadium, nearly invisible until it's too late. So next, uh, how do you know if a DDoS attack is happening? Here are some warning signs. A website or a service you use every day suddenly becomes super slow or stops working together altogether. It's like trying to open a door that's being jammed shut. Second one is there's a huge spike in traffic coming from a single source or specific group of devices. Imagine getting hundreds of calls from the same number in just a few minutes. It's very suspicious, right? Likewise, the third sign is unusual traffic patterns like sudden surges at odd hours, like 3 a.m., when no one should be that active. Next, here you can see there are many types of DDoS attacks, each with its own way to causing chaos. Let me break it down with some example. Uh, I will explain some of attacks. UDP flood first. So imagine someone sends you thousands of empty envelopes every second. You had wasted so much time opening them that you couldn't do anything else. That's what UDP flood does. It overwhelms a server with useless data. Next, SYN flood. This one tricks a server into holding onto unfinished connections. It's like reserving every table in the restaurant, but never showing up, leaving no room for real customers. So next one, HTTP flood. Think of this as a crowd of people repeatedly asking the same question over and over. The server gets so busy answering these requests that it can't handle anything else. Likewise, next one, slow lorries. This attack sends a partial request like starting a conversation but never finishing it. It ties up server's resources and leaving it unable to help anyone else. So, while each type of attack works differently, they all have same goal. That mean to overwhelm the system and shut it down. Next, we will see literature review. So, these are the literature reviews I mentioned in my review paper. I mentioned some of them. So, let's see. Uh, use realistic data. So, and second one, lightweight security model for IoT. Here, study tested a lightweight security model in a real world home network. Researchers created a botnet by infecting IoT devices and then launched a DDoS attack. They developed a detection system that blocked the attack while keeping normal traffic running smoothly. The system added minimal delays, proving it could work in real life scenarios. Next one, cloud security and DDoS attacks. Here, this study focused on protecting cloud systems from DDoS attacks. Actually, it highlighted the need for better detection and prevention methods, especially as cloud use grows. The researchers suggested using advanced machine learning and aligning new frameworks with existing security protocols, so strength defenses. Next one, lightweight algorithm for IoT networks. A new algorithm was designed to detect and stop DDoS attacks in IoT networks. Here, it works on both individual devices and network gateways using minimal power and memory. This makes it perfect for small scale environment like smart homes or hospitals, those things. The algorithm successfully identified the blocked attacks, improving overall security. Next one, software-defined networking, that means SDN for DDoS detection. Here, this study used SDN technology to capture and analyze network traffic. By its focusing on specific feature, they achieved 99.99% accuracy in detecting DDoS attack. So it's a good rate. They also found that multiple attacks happening at once can lower protocol entropy, which helps in identifying several types of threats. Next, FDNN. Uh, so here, this study introduced federated learning approach to detect DDoS attacks by training modules across multiple devices. It achieved 99.78 percentage accuracy while keeping the data private. This method is scalable and works well in IoT environments, making it a promising solution for future cybersecurity activities. Uh, so next, there's another study. So it explored creative ways to detect DDoS attacks, like using timestamps and entropy-based methods. These techniques reduce false alarms and improve detection, actually detection speed. with some methods recognizing attacks in as little as 0.015 seconds. Uh, at last, there's another study, IoT botnets and advanced detection. So here, DDoS attacks on IoT often used to rely on botnets. That mean networks of infected devices. So IoT devices are easy targets because many lack property security. Uh, and here, researchers are using lightweight neural networks and image processing to detect these botnets and it stop attacks before they cause harm to any device. So these are the some of literature reviews I used in my review paper. So next, let's talk about some research. Researchers are fighting back against DDoS attacks. So they are come up with some pretty smart solutions to protect our devices and networks. Here are here I mentioned some points. So here, federated deep neural networks uh, and entropy-based detection and software-defined network is some of solutions for these DDoS attacks. Here, what we can actually do to fix these? Here are I mentioned actually three steps, three key steps actually. So first is stronger security protocols. Here, we need to build better locks and better alarms for IoT devices from the start. Next, regular firmware updates. It's just like updating your mobile phone to fix bugs. And IoT device need regular updates. Actually, it's patch updates to patch vulnerabilities. And third one is collaboration. Here, governments, manufacturers, and cybersecurity experts need to work together to create industry-wide standards. It's like everyone in the neighborhood agreeing to lock their doors and watch out for each other. Like that, we need to work together. Then only we can save our devices from these kind of DDoS attacks. Um, at last, in conclusion part, DDoS attacks on IoT devices are actually serious threat, but they are not unstoppable. The only thing we can do is by understanding how these attacks work and implementing advanced detection and prevention methods. Then only we can protect our networks and our devices from these kind of DDoS attacks. So in future of IoT depends on our ability actually. Uh, that means the future of IoT depends on our ability to secure it. Let's invest in better security measures and work together to create a safer, more resilient digital world. This is the summary of my review paper. Thank you so much for this opportunity.